Okay, so we want to find the area underneath this disk of the function xy, where D is the region bounded by the lines y equals x minus 1 and y squared is equal to 2x plus 6. So first we want to do is just graph this out. And we could either do one to two ways. We can take the square root of each side so you can see how it would work. And this is usually just plus or minus this. Or you can just break it up knowing it's going to be symmetric across the x-axis. So plug in 0, you get 6 out for y. Right, so we plug in 0, you get square root of 6, so it's roughly, let's say, here-ish. And same thing on the other side. You plug in 1, and you arbitrate it close to what we want. So I'm going to find the vertex, and the vertex is when you plug in 3 in for negative 3 in for x, so way over here. So if I plug in negative 3 in, if I get 0. So my function, or my parabola, looks kind of like this. And on the other side, starts here and just goes 1 up over 1, right? It's our basic graph. So the region what we're doing, or our D region, is right here. Okay. Now to find the bounds, you could just plug it in and solve for x. So you would have to plug in y equals that, so you'd have to FOIL and put everything together. So this is just going to give you x squared minus 2x plus 1 is equal to 2x plus 6. Bring everything to one side and factor it. So if you notice, this is going to be negative 5, negative 4. So two numbers, when you multiply, give you the top, and add up, they give you the bottom. It looks like negative 5 and 1 work. So your answers are 5 and negative 1. So at this point here, it's 5 comma something, and at this point here, it's negative 1 comma something, and then you just plug it in. So we'll plug it into the easier of the two. So if I plug in 5, I get 4 out. And if I plug in 1, I get negative 2 out. So those are our points there. Okay. All right, so now we want to find this integral boundary between these two curves. Now, like, you can go this way if you like. The only problem with that portion is you're going to break up your integral into 2 or even 3 different parts, because at this point it's this minus this. But as you get down here, it's opposite, because now you get plus or minus. So the top will be plus this, and the bottom will be minus it. So you have 2 different integrals you're adding together, or 2 double integrals added together. And since, integration is already difficult to begin with, you kind of don't want to do that. So instead, we're going to do a type 2 one, and it's going this way. It's going up and down. So because it's going up and down, therefore, x is going to be bounded between the values, the functions of y, and then y is going to be bounded between 2 values itself. So in this case, y is going to be bounded between here and there. So in other words, from negative 2 to 4. And therefore, x is going to be bounded between the functions. So that means we're just going to solve for x in each individual case. So this brings it over here. So it'll be y plus 1 equals x, which is this one right here. And since we always do right minus left, so this is going to be the very top. And this one, when we solve for x, is going to be the very bottom. And that's simply just subtracting over the 6 and then dividing by 2. So now we put our bounds, so now we're just going to take the integral from -2 to 4, and then on the inside it's going to be the x values. Of our function x, y, dx, dy. So integral with respect to x is going to give you x squared y over 2, evaluated at these two functions. Okay. So now if I plug this in for x, oops, sorry, this is a y. Nope, yep, this must be a y. Okay, there we go. Yep, perfect. So now if I plug this in, I'm going to have y on the outside and y plus 1 squared all over 2 minus y over 2 times y squared minus 6 over 2 all squared. Okay. Now this part here is y squared plus 2y plus 1. And this part right here is y to the 4th minus 12y squared plus 36. Okay. All right, so if I distribute the y, I now get y to the 3rd minus 2y squared plus y all over 2. And if again I distribute this y on the very top, I get y to the 5th minus 12y to the 3rd plus 36y. All over 2 squared is 4 times 2 gives you the 8. Okay. Now this is where I messed up on the last part, is right here. I forgot to distribute the y, and it fused everything up. So what I'm going to do is make this a little easier to look at, is I'm going to factor out a 1/8. So when I factor out a 1/8, that means I'm multiplying this side by 4 to get the 1/8 at the bottom. Right? So if I multiply 4 over 4, that gives you like literally just putting the fractions together. So this ends up being 4y a third minus 8y squared plus 4y. And distributing this negative, now I can put everything with no fractions underneath. Like that. And now I just collect my terms as much as I can. So this is by itself. Cubes I could put together. So that's going to give you 16. Only 1/8. And then these together give you negative 32y. So now I'm integrating this with respect to y now, with this 1/8 on the outside, from -2 to 4. So now this becomes negative y to the 6 over 6 plus y to the 4th times 4 minus y to the 3rd 8 plus y squared 16. All evaluated from -2 to 4 times that 1/8 on the outside. So now once you plug in 4 and 2, so this is what we get. So this gives us, oh, just realized, this is a plus, so just change, so I gotta change this to pluses, this to a plus, this to a plus, and then this to a plus. There we go. That changes it a lot. So now, if I plug in 4 and -2, I get something outrageous, and I'll just break it down for you. So that's when you plug in x equaling to 4. And if you add up all this, you actually get 256. And now if you plug in -2 in for x, this is what I get. And if you add and subtract all that, you get -32. Okay. So therefore we add them, so 256 plus 32 gives us a grand total of 288. And then don't forget, because we had that 1/8 on the outside, we divide our final answer by 8. So divide by 8. And our final answer after all of this integration is 36. Okay. So I'll just quickly go over that example there.